So you are asked to solve this problem using node voltage method and to solve for the branch voltage VO. The first thing that you have to do is find the essential nodes and label them. I'm gonna label this one, this one, this one, V2, and you use one as reference. You have 4 essential nodes and you use one as reference. So what this means is that you will have to find 3 equations. But due to the fact that you have a current dependent voltage source here, we're gonna go another route. What we're gonna do is we're gonna state the equation for VO, which is VO minus V1 over 10 plus VO over 40 plus VO minus V2 over 20 equals 0. This is going to be our first equation. We could simplify a little more. Right, VO 1 over 10, 1 over 40, 1 over 20 minus V1 1 over 10 minus V2 1 over 20 equals 0. Now, there's 2 things that we have to notice from this figure, and it is that the voltage from the reference 0 from ground to this node right here is in parallel with this voltage. So V1 is equal to 10. And the same thing happens here. From this reference, ground, to this node here, V2 equals this dependent is equal to the value of the dependent voltage source. So we could write that V1 is equal to 10 volts in another color. This color is kind of too bright. V1 is equal to 10 volts and V2 is equal to negative 20 I delta. Why negative? Because if you notice, V2 will be positive here, negative here. But if you notice, that's the reference. But this voltage source, this dependent voltage source, says that it's negative in this direction and positive in this direction. So it's inverse. Knowing these 2 voltages, we can substitute them into our equation, and let's solve these fractions. Let's group them all together with our calculator. Let's not go to the trouble of doing it algebraically. We have 7 over 40 plus V1 that we know it is 10, minus over 10 minus 20 I delta over 20 equals 0. So we have 7 over 40 VO. We have plus 20 over 20 is 1. And we're going to pass 10 over 10 is 1. We're going to pass it summing to the other side. We pass this summing over here. We're going to cancel this. And this is 1. And this is, well, it's 1 also. So this is our equation. Our first equation. Now, let's notice something from this figure. And it is that current I delta is divided into two currents here. It's divided into a current, let's name it I1. Let's name this I2. So I delta equals I1 plus I2. I1 is V1 minus V2 over 30, and V2 is V1 minus VO over 10. We know that V1 is 10, so it will be 10 over 30 minus V2, and we know that V2 is negative 20 I delta over 30 plus V1 that we know is 10 minus VO over 10. So we have I delta. We can pass this value here. First, we could simplify this. And minus is plus. So we have 2/3 I delta plus 1/3 from here plus 1 from here minus VO over 10. We could pass this to the other side. Subtracting. And 1/3 plus 1 is 1 plus 3 over 3, finding a common denominator, minus VO over 10. And 1 minus 2/3 is 3 minus over 3. This is equal to 3, 4 third. And this is equal to 1/3. We can pass this sum into this side. And if you notice, this is our second equation. So we could take this equation in this equation and put it in standard form, by passing, sorry, this over, this over, and we'll be left with 7 over 40 plus 1 over 10, 1 over 3. This is a matrix. We have VO, we have I delta is going to equal one. Now we have a matrix, a 2 by 2 linear equation. So we could just use our calculator. We have 7 over 40 plus 1 equals 1, and 1 over 10 plus 1/3 equals 4/3. And we are left with VO is equal to 24 volts, and I delta is equal to negative 3.2 amps. And that is your result.